The ocean is vast, mysterious, and mostly invisible to us. Imagine descending through layers of water, each one darker and stranger than the last. At the surface, sunlight dances through crystal blue waves, but as you sink deeper, the light begins to fade. First the reds disappear, then the oranges and yellows until only a haunting blue remains. Deeper still, and even that blue dissolves into an endless velvet darkness. This is where our story begins, in a world that covers more than 60% of our planet yet remains more mysterious than the surface of Mars. Below the waves, beyond the reach of sunlight, life thrives in ways that seem utterly alien to us. Here, creatures exist without known predators, species that glow with their own inner light, beings that vanish like ghosts, and organisms that outlive centuries as if time itself moves differently in the depths. Every expedition into the deep reveals something that challenges everything we thought we knew about life on Earth. Submersibles descend miles below the surface, only to encounter creatures so strange they might as well have evolved on another world. Some have eyes the size of dinner plates, others have no eyes at all. Some generate their own light shows, while others remain perfectly invisible until the moment they strike. The pressure down there would crush a human body instantly, yet life not only survives but flourishes in ways that defy our understanding. The cold is so intense it would freeze blood in seconds, yet the deep ocean pulses with activity. It is a realm where the impossible becomes routine, where biology itself seems to follow different rules. And every so often we discover something that shouldn't even exist. Something that makes us question not just what we know about the ocean, but what we know about life itself. These are the stories that pull us into the abyss, tales of creatures so extraordinary they blur the line between science and wonder. Tonight, we descend into that darkness together, following the light of bioluminescent guides through a world where every shadow might hide a mystery, and every discovery reveals just how little we truly understand about the planet we call home. In the vast expanse of the Pacific Ocean, marine biologists made a discovery that would haunt their dreams for decades. A massive sperm whale, one of the ocean's most formidable predators, surfaced bearing wounds unlike anything they had ever seen. Across its scarred hide were circular marks, each one larger than a dinner plate, arranged in perfect symmetrical patterns. These were sucker scars, the calling cards of a cephalopod encounter, but their size defied all known science. The largest giant squid ever recorded, the legendary Architeuthis, possessed suckers no bigger than a human palm. Yet here was evidence of a creature whose suckers were 3 times that size, maybe 4. The mathematics were staggering and terrifying. If sucker size correlates with body mass, then somewhere in the crushing depths below, something enormous was waiting. Sperm whales are no strangers to deep-sea combat. They dive deeper than any other whale, plunging down 2,000 meters or more to hunt in the midnight zone. Their heads are battering rams, their jaws lined with teeth like ivory daggers. They are built for battle, evolved over millions of years to be the ultimate deep-sea predator. Yet this whale bore the scars of something that had fought back with devastating effectiveness. The wounds told a story of struggle, of a battle fought in absolute darkness under pressure that would crush a submarine. The circular marks were not random scratches but precise impressions, as if massive suction cups had gripped the whale's flesh with incredible force. Some scars were fresh, still healing, while others had faded to pale silver lines that spoke of encounters survived years before. Dr. Malcolm Clark, one of the world's leading experts on cephalopods, spent years studying these mysterious scars. In his laboratory in Plymouth, England, he carefully measured and catalogued each wound, creating a database of encounters that spanned decades. The patterns he discovered were both fascinating and deeply unsettling. The scars showed a consistent size progression, suggesting that whatever creature was responsible continued to grow throughout its lifetime, reaching sizes that challenged everything scientists thought they knew about the limits of life in the deep ocean. Marine biologists began collecting similar evidence from whales around the world. Off the coast of New Zealand, a bull sperm whale carried scars from suckers estimated to be over 30 centimeters across. In the waters near Antarctica, researchers found wounds that suggested an encounter with something possessing arms thicker than a human torso. Each discovery painted a picture of a creature that dwarfed even the colossal squid, that mythical giant of the southern seas. The implications were staggering. If such a creature existed, it would represent the largest predator in Earth's oceans, possibly the largest predator that had ever lived. But despite decades of searching, despite thousands of deep-sea expeditions and millions of hours of underwater footage, no human had ever seen such a beast alive. The mystery deepened when researchers analyzed the feeding behavior of sperm whales. These giants consume nearly a ton of food each day, yet their primary diet consists of medium-sized squid. The energy expenditure required to dive to such depths, to battle creatures large enough to leave those massive scars, seemed to outweigh any nutritional benefit. Unless, of course, the whales were not hunting these giants, but were being hunted by them. This possibility opened up an entirely new perspective on deep-sea ecology. Perhaps the sperm whale, apex predator of the surface world, was merely prey in the deepest reaches of the ocean. The scars suggested encounters that lasted for extended periods, battles of endurance fought in the crushing darkness where neither creature could surface for air. The whales that bore these marks were survivors, witnesses to encounters with something that most of their kind did not live to tell about. Deep-sea cameras began capturing strange shadows at the very limits of their range, massive forms that seemed to move with purpose through the abyss. Sonar readings detected objects of enormous size traveling at impossible speeds through the deep ocean trenches, but every time researchers tried to investigate, the objects vanished as if they had never existed at all. The phenomenon became known among deep-sea researchers as the ghost contact problem. Sophisticated sonar arrays would detect massive objects moving through the deep ocean, objects far too large to be whales or any known marine life. Yet when submersibles were dispatched to investigate, they found nothing but empty water and the occasional startled deep-sea fish fleeing from lights that had never before penetrated their world. Some researchers began to suspect that these creatures possessed a form of intelligence that allowed them to detect and avoid human technology. The timing of the disappearances was too consistent to be coincidental. It was as if something vast and ancient was playing a game of hide-and-seek with humanity's most advanced deep-sea exploration equipment. The giant squid, once thought to be myth, was finally photographed alive in 2004. The colossal squid, even larger and more mysterious, began yielding its secrets to science. But the creature responsible for those massive scars remained hidden, a ghost in the machine of deep-sea exploration. Evolution in the deep ocean follows different rules than life near the surface. The pressure, the cold, the absolute darkness, and the scarcity of food all combine to create an environment where only the most perfectly adapted can survive. In such conditions, gigantism often emerges as a survival strategy. Larger bodies retain heat more efficiently. Larger eyes can gather more of the precious little light that filters down from above, and larger size provides protection from predators. But there are limits to how large a creature can grow while still maintaining the ability to move efficiently through water. The square cube law dictates that as an animal increases in size, its volume and weight increase much faster than its surface area. This means that beyond a certain point, a creature becomes too heavy to swim effectively. Yet the evidence suggested something had found a way around this fundamental limitation. Perhaps the answer lay in the creature's anatomy. The deep ocean giants that science had already discovered possessed bodies adapted in remarkable ways to their environment. The colossal squid's flesh was filled with ammonia, making it neutrally buoyant despite its massive size. Perhaps this unknown giant had evolved even more sophisticated adaptations, allowing it to achieve sizes that would be impossible for surface-dwelling creatures. The search continued with ever more sophisticated technology. Deep-sea robots equipped with advanced cameras and sensors were deployed to the deepest trenches on Earth. Military sonar arrays, originally designed to track submarines, were repurposed to listen for the sounds of massive creatures moving through the abyss. Satellite tracking of sperm whales was enhanced to identify those individuals that carried the largest scars, in hopes of following them to their mysterious encounters. But the ocean kept its secrets. Each expedition returned with tantalizing hints but no definitive proof. A shadow glimpsed at the edge of a camera's range, a sonar contact that vanished before it could be properly analyzed. Fresh scars on whales that had been photographed unmarked just months before. Perhaps it dwells in trenches so deep that no human technology can reach it. Perhaps it surfaces only in the darkest hours of the night, in waters so remote that no vessel has ever disturbed its domain. Or perhaps it is watching us even now, its massive eyes reflecting the lights of our submersibles as we pass unknowingly overhead, never suspecting that we are being observed by something that sees us as nothing more than curious visitors to its ancient realm. Are we glimpsing the arms of a creature that dwells where no light can reach, or the battle scars of something even more ancient, something that has made the deepest places of the ocean its home for countless millennia? The answer waits in the darkness, patient and eternal, as it has waited since long before humans first gazed upon the sea and wondered what secrets lay beneath its surface. Deep in the vast Pacific Ocean, a song echoes through the darkness that has captivated scientists and broken hearts around the world. It is a call unlike any other, a voice that speaks in frequencies no other whale understands. For over 3 decades, researchers have tracked this solitary singer, a creature that has become known as the 52 Hertz whale, and its story is one of the most haunting mysteries of the deep sea. The discovery began in the late 1980s, when the United States Navy's hydrophone arrays, originally designed to detect enemy submarines during the Cold War, began picking up an unusual sound. At exactly 52 Hertz, far higher than any known whale song, this call cut through the ocean's ambient noise with startling clarity. Unlike the deep, resonant songs of blue whales that rumble at 10 to 39 Hertz, or the complex melodies of humpback whales, this voice sang alone at a frequency that seemed to belong to no known species. Marine biologist William Watkins was the first to recognize the significance of this discovery. Working at the Woods Hole Oceanographic Institution, Watkins had spent his career listening to the sounds of the sea, but nothing had prepared him for this enigmatic voice. Year after year, the same distinctive call appeared on hydrophone recordings, always at that precise frequency, always traveling the same migration routes as other great whales, but always alone. The pattern was both fascinating and heartbreaking. Here was a creature following the ancient pathways of its kind, calling out into the darkness, but receiving no response. The song itself is hauntingly beautiful. Unlike the structured phrases of humpback whale songs or the simple calls of blue whales, the 52 Hertz whale's vocalizations are complex and varied. Its calls can last for hours, rising and falling in pitch within that narrow frequency band, sometimes urgent and repetitive, other times long and mournful. To human ears, processed through sophisticated recording equipment, these songs sound almost conversational, as if the whale is trying to tell a story that no one else can understand. The whale's voice has a quality that seems almost human in its emotional resonance. When researchers slow down the recordings and lower the pitch, the calls take on an even more poignant character, resembling the long, drawn-out cries of someone calling across a vast, empty space. The songs vary in intensity and duration, suggesting that the whale experiences different emotional states, perhaps loneliness, frustration, hope, or even joy. But without other whales to respond, these emotional nuances remain locked in a language that only the singer understands. Scientists have proposed several theories about the origin of this mysterious singer. The most widely accepted explanation suggests that it might be a hybrid, the offspring of a blue whale and a fin whale, 2 species that occasionally interbreed. Such hybrids are extremely rare, and their vocal anatomy might produce calls at frequencies that fall between those of their parent species. If this is the case, then the 52 Hertz whale represents a unique individual, neither fully one species nor the other, singing in a voice that bridges 2 worlds but belongs to neither. The hybrid theory gains support from the whale's behavior patterns. Like blue whales, it appears to be a filter feeder, following the same migration routes that blue whales use to track krill blooms. But like fin whales, it seems to be more solitary, less likely to travel in groups. This combination of traits would be consistent with a hybrid animal, inheriting characteristics from both parent species, but not fully fitting into either community. Another possibility is that the whale suffered some form of physical deformity or injury that altered its vocal anatomy. Whales produce their songs using specialized structures in their heads called phonic lips, and even small changes to these organs could dramatically affect the pitch of their calls. If the 52 Hertz whale was born with or developed such an abnormality, it would explain why its voice is so different from others of its species. The consistency of its frequency over the years suggests that this is not a temporary condition, but a permanent characteristic of the animal's anatomy. But perhaps the most intriguing theory is that this whale represents something entirely new, a genetic anomaly, or the first member of a new species adapting to the changing acoustic environment of the modern ocean. The seas have become increasingly noisy over the past century, filled with the sounds of ship engines, sonar arrays, and industrial activity. Perhaps the 52 Hz whale's unique frequency allows it to communicate more effectively in this new acoustic landscape, its calls cutting through the human-generated noise that drowns out the traditional songs of its kind. The noise pollution of modern oceans is a serious concern for marine biologists. The low-frequency calls of blue whales, which once traveled across entire ocean basins, are now often masked by the rumble of cargo ships. Military sonar can disrupt whale migration patterns and cause strandings. The constant background noise of human activity has forced many whale species to change their calling behaviors, singing louder, longer, or at different frequencies to be heard above the din. The whale's migration patterns have been carefully tracked over the decades, and they reveal a creature that follows the same routes as other great whales, traveling thousands of miles between feeding and breeding grounds. It moves from the cold, nutrient-rich waters of Alaska down to the warmer seas off California and Mexico, timing its movements with the seasonal changes that have guided whale migrations for millions of years. Yet it makes this journey alone, its calls echoing through empty water. The tracking data reveals something particularly poignant about this whale's behavior. During the times of year when other whales gather in large groups for feeding or breeding, the 52 Hz whale's calls become more frequent and more intense. It is as if the whale can sense the presence of others of its kind and is trying desperately to join their conversations, calling out in its unique voice in hopes that someone, somewhere, will understand. The loneliness of this creature has captured the imagination of people around the world. Artists have created paintings and sculptures inspired by its song. Musicians have composed symphonies that incorporate recordings of its calls. Writers have penned stories and poems about this solitary wanderer of the deep. The 52 Hz whale has become a symbol of isolation in our connected world, a reminder that even in the vast ocean it is possible to be utterly alone. Documentary filmmakers have attempted to capture the essence of this whale's story, but the challenge is immense. How do you film a creature that has never been seen, whose only known presence is a voice in the darkness? Some have created artistic interpretations, using abstract imagery and music to convey the emotional weight of the whale's solitude. Others have focused on the scientists who study it, exploring the human fascination with this mysterious creature. But is this whale truly alone, or are we simply unable to detect its companions? The ocean is vast, and our listening posts are scattered and limited. It is possible that other whales respond to its calls in ways we cannot detect, using frequencies or communication methods that our instruments cannot pick up. Whales are known to use infrasonic calls that travel for thousands of miles, and it is conceivable that the 52 Hz whale receives responses that we have never heard. Recent advances in acoustic monitoring have begun to reveal the incredible complexity of whale communication. Scientists have discovered that whales can modify their calls in real time, adjusting their frequency and volume based on environmental conditions and the presence of other whales. They use acoustic lenses in their heads to focus their songs like underwater spotlights, directing their calls towards specific targets. If the 52 Hz whale possesses such abilities, it might be engaged in conversations that we are only beginning to understand. The whale's song has also changed over time, becoming slightly deeper as the years have passed. This could be a sign of aging, as the whale's vocal anatomy changes with maturity, or it might indicate that the whale is learning, adapting its calls in response to the changing acoustic environment of the ocean. Some researchers have suggested that the whale might be trying to lower its frequency to match the calls of other whales, a heartbreaking attempt to find its voice in a world that doesn't seem to hear it. The search for the 52 Hz whale continues, but despite decades of tracking its calls, no human has ever seen this creature. It remains a voice without a face, a song without a singer, a presence felt but never observed. Advanced tagging programs have been developed specifically to locate and identify this whale, but the ocean is vast and the whale's exact location remains elusive. new technologies offer hope for finally solving this mystery. Autonomous underwater vehicles equipped with sophisticated acoustic sensors can now follow whale calls for extended periods, potentially leading researchers directly to the 52 Hz whale. Satellite tracking systems can monitor vast areas of ocean simultaneously, looking for the unique acoustic signature of this solitary singer. And advances in genetic analysis might soon allow scientists to determine the whale's species and origin from a single drop of seawater containing its DNA. Perhaps the 52 Hz whale represents something more profound than a simple biological anomaly. In our age of global communication, when we can instantly connect with people on the other side of the world, this whale reminds us that connection is not always possible, that sometimes we speak into the void and hear only our own voice echoing back. Its song is a meditation on loneliness, on the courage it takes to keep calling even when no one seems to be listening. The whale's story also speaks to the resilience of life itself. For decades, this creature has continued its migrations, continued its songs, continued to live and thrive despite its isolation. There is something deeply moving about this persistence, this refusal to give up hope that somewhere in the vast ocean another voice might answer. Is this a biological anomaly, a creature born out of step with its own kind, or the first voice of a species we have yet to discover? The answer may lie in the deep waters where the whale continues its eternal journey, singing its lonely song into the darkness, waiting for a response that may never come, or perhaps has always been there, just beyond our ability to hear. In the icy waters surrounding Antarctica, beneath miles of dark ocean where the pressure would crush steel submarines like paper cups, lives a creature so extraordinary that science has only glimpsed it in death. The colossal squid, known to researchers as Mesonychoteuthis hamiltoni, represents one of the ocean's greatest paradoxes. We know it exists because we have held its massive form in our hands, measured its impossible dimensions, and marveled at its alien anatomy. Yet no human has ever witnessed this titan alive in its natural habitat. Unlike its famous cousin, the giant squid, which has finally yielded to underwater cameras and been photographed in the wild, the colossal squid remains a ghost of the deep. Every specimen we have studied has been dead, either floating lifeless at the surface or pulled from the stomach of a sperm whale. Each discovery brings more questions than answers, painting a picture of a creature so perfectly adapted to the abyss that it exists beyond the reach of human observation. The first hint of the colossal squid's existence came in 1925, when scientists examining the stomach contents of a sperm whale discovered tentacle arms unlike anything they had seen before. These weren't the smooth, sucker-lined appendages of the giant squid, but something far more sinister. Along their length ran rows of sharp, rotating hooks, each one capable of swiveling like a meat hook to maintain its grip on struggling prey. The implications were staggering. Here was evidence of a predator that didn't just grab its victims but impaled them. For decades, these tantalizing fragments were all science had to work with. A hook here, a tentacle there, occasional glimpses of what might be the largest invertebrate predator on Earth. But the creature itself remained hidden in the depths, dwelling in waters so remote and hostile that human technology could barely reach them, let alone document what lived there. The breakthrough came in 2003 when New Zealand fishermen working the waters above the Ross Sea hauled up something that would rewrite the textbooks on deep sea life. Entangled in their lines was a colossal squid, recently dead but intact enough to reveal secrets that had been hidden for millennia. The specimen was enormous, measuring over 4 meters in length even though it was clearly a juvenile. Its eyes, each one the size of a basketball, were the largest known in the animal kingdom, perfectly adapted to gather the faintest traces of light in the eternal darkness of the deep. Dr. Steve O'Shea, one of the world's leading teuthologists, was among the first to examine this remarkable find. In his laboratory in Auckland, he carefully dissected the creature, documenting each extraordinary adaptation. The hooks on its tentacles were even more sophisticated than the fragments had suggested. Not only could they rotate to maintain grip, but they were sharp enough to penetrate bone. The squid's beak, hidden at the center of its writhing arms, was larger than a human fist and composed of a material harder than most metals. But it was the creature's overall anatomy that truly astounded researchers. Unlike the giant squid, which is built for speed and agility, The colossal squid appeared to be a living ambush predator. Its body was shorter and more robust, its arms thicker and more muscular. Most remarkably, its flesh was saturated with ammonia, making the entire animal neutrally buoyant despite its massive size. This adaptation allowed it to hover motionless in the water column, a patient hunter waiting for prey to venture within range of its deadly embrace. The eyes told their own story of life in the abyss. At 27 centimeters in diameter, they were not just the largest eyes of any known animal, but represented a significant portion of the creature's metabolic investment. In the deep ocean, where sunlight has never penetrated and bioluminescence provides the only illumination, such massive eyes serve as biological light amplifiers. They can detect the faintest glow from bioluminescent prey or the subtle silhouettes of creatures passing between the squid and what little light filters down from the distant surface. These eyes also revealed something else extraordinary. Embedded within them were specialized muscles that could change their shape, essentially creating biological telephoto lenses. The colossal squid could zoom in on distant targets with a precision that would be the envy of any submarine commander. In the vast emptiness of the deep sea, where encounters with prey might be rare, such visual acuity could mean the difference between a successful hunt and starvation. As more specimens were discovered, each one told a piece of the colossal squid's story. A juvenile caught in 2007 revealed that even young colossal squids possessed the full complement of hooks and hunting adaptations, suggesting that they are born as perfectly functional predators. An adult specimen found floating near the surface in 2008, measuring over 10 meters in length, showed scars that could only have come from battles with sperm whales, proof that these giants engage in combat that would dwarf any struggle ever witnessed by human eyes. The geographic distribution of colossal squid discoveries has gradually revealed the scope of their domain. Every specimen has been found in the Southern Ocean, in the deep waters surrounding Antarctica, where the convergence of cold currents creates a unique ecosystem. Here, in the most isolated waters on Earth, the colossal squid has evolved in splendid isolation, becoming something that seems more myth than reality. Yet, for all we have learned from these specimens, the fundamental mystery remains. How does a creature of such size and power live in the deep ocean? What does it hunt? How does it reproduce? How long does it live? The answers remain locked in the abyss, guarded by crushing pressure and eternal darkness. Computer models based on the specimens suggest that adult colossal squids could reach lengths of 14 meters or more, with tentacles capable of extending even further. Their weight could exceed 700 kilograms, making them among the largest predators ever to exist on Earth. Yet despite their size, they appear to be masters of stealth, perfectly adapted to remain invisible in their dark domain. The few clues we have about their behavior come from the stomach contents of sperm whales, their only known predator. The presence of colossal squid beaks in whale stomachs tells us that these encounters are not uncommon, but the condition of the beaks suggests that the squids do not go quietly. Many show signs of damage from the whale's teeth, evidence of desperate struggles fought in the crushing depths where neither creature can surface for air. Some researchers have proposed that colossal squids might be cannibalistic, with larger individuals preying on smaller ones. This would explain their robust build and powerful hooks, adaptations that would be useful for subduing prey of their own species. In the nutrient-poor environment of the deep Antarctic waters, cannibalism might be a necessary survival strategy for maintaining such enormous body size. The reproductive biology of colossal squids remains almost entirely unknown. Like other squid species, they are probably semilparous, meaning they reproduce once and then die. But when and where this reproduction occurs, how they find mates in the vast emptiness of the Southern Ocean, and how long they live before that final reproductive act are questions that may take decades to answer. Recent advances in deep-sea exploration technology offer new hope for finally observing a living colossal squid. Ultra-deep diving vehicles capable of reaching the greatest depths of the Southern Ocean are being developed specifically for this purpose. Advanced camera systems that can operate in total darkness using infrared and other non-visible wavelengths might finally capture images of these creatures in their natural habitat. But perhaps the colossal squid's greatest mystery is not biological but philosophical. Here is a creature that represents the absolute pinnacle of predatory evolution in the deep sea, yet it remains completely hidden from human observation. It is a reminder that our planet still holds secrets beyond our imagination, creatures so perfectly adapted to their environment that they exist in a realm as alien to us as the surface of another world. The colossal squid challenges our understanding of what is possible in the deep ocean. Its very existence pushes the boundaries of how large, how sophisticated, and how alien life can become in the hidden depths of our own planet. We have seen what it looks like in death, have marveled at its impossible anatomy, and speculated about its mysterious life. But the creature itself, alive and hunting in the eternal darkness of the Antarctic abyss, remains one of the ocean's most closely guarded secrets. What if the colossal squid we have found are not the largest examples of their kind? What if, in the deepest trenches of the Southern Ocean, even more massive specimens dwell in perfect darkness, creatures so enormous and so perfectly adapted to the abyss that they represent the ultimate expression of life in the deep sea? The answer waits in the darkness, patient and eternal, as it has waited since the first colossal squid descended into the depths millions of years ago. In the folklore of coastal Japan, there exists a creature known as the Ryugu no Tsukai, the messenger from the sea god's palace. It is said that when this serpentine being rises from the depths to show itself to human eyes, the earth itself will soon tremble. This messenger is the Oarfish, a ribbon-like giant that can stretch longer than a school bus, yet remains one of the most mysterious inhabitants of our oceans. For centuries, its rare appearances at the surface have been followed by seismic events so consistently that modern science has been forced to take seriously what was once dismissed as mere superstition. The Oarfish, known scientifically as Regalicus glesner, is a creature that seems to have emerged from the pages of ancient mythology. Its body is a living ribbon of silver, undulating through the water with movements so fluid they appear almost supernatural. These remarkable fish can reach lengths of over 10 meters, making them the longest bony fish in the world, yet they are rarely more than a few centimeters thick. Their bodies are adorned with a magnificent dorsal fin that runs almost their entire length, creating a crown-like crest that has earned them the name King of Herrings. Under normal circumstances, oarfish dwell in the twilight zone of the ocean, that mysterious realm between 200 and 1,000 meters below the surface where sunlight fades to nothing and bioluminescence becomes the primary source of illumination. Here, in the perpetual darkness, they glide vertically through the water column like living exclamation marks, their bodies oriented head up as they hunt for small fish and squid. Their preferred habitat is so deep and so rarely visited by humans that sightings of living oarfish are extraordinarily rare. But sometimes, for reasons that science is only beginning to understand, these deep-dwelling giants abandon their abyssal home and venture toward the surface. When they do, coastal communities often find their beaches littered with the silvery bodies of these magnificent creatures, their ribbon-like forms stretched across the sand like messages written in an unknown language. And time after time, these mass strandings have been followed by earthquakes, often of significant magnitude and sometimes devastatingly close to where the oarfish first appeared. The most dramatic example of this phenomenon occurred in the months leading up to the Great Tohoku earthquake and tsunami of March 11, 2011. In the preceding year, an unprecedented number of oarfish had been spotted in Japanese waters. Fishermen reported hauling up the strange serpentine creatures in their nets. Divers encountered them swimming near the surface, their normally deep-dwelling forms visible in shallow coastal waters. Beach walkers found their bodies washed ashore along hundreds of kilometers of coastline. Local newspapers began reporting on the unusual sightings, and marine biologists noted the anomaly in their research logs. But it was only after the magnitude 9 earthquake struck off the coast of Honshu, triggering a tsunami that would devastate the Japanese coastline and damage the Fukushima nuclear plant, that people began to seriously consider the connection. The earthquake was one of the most powerful ever recorded, and the pattern of oarfish sightings that preceded it was unlike anything in the scientific literature. Dr. Kiyoshi Wadatsumi, a seismologist at the University of Tokyo, was among the first to propose a scientific mechanism for the oarfish earthquake connection. His research suggested that these deep-sea fish might be sensitive to the subtle changes in electromagnetic fields and water chemistry that occur before major seismic events. The theory was revolutionary because it implied that the deep ocean, long thought to be isolated from geological processes, might actually be intimately connected to the movements of the Earth's crust. The electromagnetic field hypothesis gained support from studies of other animals that seem to exhibit pre-earthquake behavior. Dogs bark incessantly, cats hide, and horses refuse to enter their stables in the hours before major tremors. Laboratory experiments have shown that many animals are sensitive to infrasound, the low-frequency sound waves that travel through the Earth's crust before earthquakes. If oarfish possess similar sensitivities, they might detect the subtle precursors to seismic events long before human instruments register any abnormality. But the mechanism might be even more complex than simple electromagnetic sensitivity. Oarfish inhabit the deep scattering layer, a zone of the ocean where vast numbers of small organisms migrate vertically each day, rising toward the surface at night to feed and descending back to the depths before dawn. This daily migration is one of the largest movements of biomass on Earth, and it is exquisitely sensitive to changes in the ocean environment. Before major earthquakes, the seafloor itself may undergo subtle shifts that create pressure waves in the deep ocean. These waves could disrupt the delicate balance of the deep scattering layer, confusing the oarfish and causing them to lose their normal orientation. Unable to maintain their preferred depth, they might rise toward the surface where the unfamiliar pressure and temperature eventually prove fatal. Another possibility involves the release of gases from the seafloor before earthquakes. As tectonic stress builds along fault lines, microscopic fractures may appear in the ocean bottom, releasing methane and other gases that have been trapped in sediments for thousands of years. These chemical changes could alter the behavior of the small organisms that oarfish depend on for food, forcing the predators to venture into unfamiliar territory in search of prey. The oarfish phenomenon is not limited to Japan. Similar correlations between deep-sea fish strandings and seismic activity have been reported along the coasts of Chile, Peru, and California. In each case, the appearance of normally deep-dwelling species at the surface has been followed by significant earthquakes within weeks or months. The consistency of these reports across different cultures and geographic regions suggests that the connection is real, not simply a product of confirmation bias or cultural expectation. However, the scientific community remains divided on the significance of these correlations. Skeptics point out that earthquakes are relatively common events, particularly in seismically active regions like the Pacific Ring of Fire. They argue that if one looks hard enough for correlations between unusual animal behavior and earthquakes, such patterns will inevitably emerge by chance. The challenge is distinguishing genuine precursory behavior from random coincidence. Recent advances in deep-sea monitoring technology have begun to provide new insights into the oarfish mystery. Autonomous underwater vehicles equipped with acoustic sensors can now track the movements of deep-sea fish populations in real time, potentially revealing changes in behavior that precede seismic events. Seismometers placed on the ocean floor can detect the subtle vibrations that may trigger oarfish disorientation, while chemical sensors monitor for the release of gases that could disrupt the deep-sea ecosystem. One of the most intriguing aspects of the oarfish phenomenon is its apparent specificity. While many deep-sea species occasionally strand themselves on beaches, few show the consistent correlation with earthquakes that oarfish display. This specificity suggests that these creatures possess some unique sensitivity or behavioral trait that makes them particularly vulnerable to pre-seismic disturbances. The anatomy of oarfish provides some clues to their mysterious behavior. Their lateral line system, which detects water movement and pressure changes, is extraordinarily well developed. This sensory network might allow them to perceive subtle changes in water pressure or current patterns that accompany the buildup of tectonic stress. Their elongated body shape might also make them more sensitive to electromagnetic fields, as their entire length could function as a biological antenna. Cultural interpretations of oarfish appearances vary widely around the world, but many share the common theme of these creatures serving as harbingers of geological upheaval. In Filipino folklore, the appearance of large, deep sea fish is said to herald not just earthquakes, but also volcanic eruptions. Mexican coastal legends speak of serpentine sea creatures that rise from the depths before the earth shakes. These cultural memories, passed down through generations of coastal peoples, suggest that the oarfish-earthquake connection has been observed for centuries. Modern technology is beginning to test these ancient observations with unprecedented precision. Satellite monitoring systems can now track the movement of large marine animals across entire ocean basins, potentially revealing migration patterns that correlate with seismic activity. Genetic analysis of stranded oarfish might reveal whether these individuals come from specific populations or represent a random sampling of the deep-sea community. The implications of the oarfish phenomenon extend far beyond marine biology. If these creatures truly can sense impending earthquakes, they might serve as an early warning system for coastal communities. The challenge lies in distinguishing genuine precursory behavior from the normal variations in marine animal distribution that occur due to changes in ocean temperature, currents, and food availability. As our understanding of the deep ocean improves, the line between folklore and science continues to blur. The oarfish, once dismissed as a creature of myth and superstition, now stands at the center of serious scientific inquiry into the connections between the living ocean and the restless earth beneath it. Whether these ribbon-like giants are truly messengers from the deep, warning of geological upheaval to come, or simply victims of environmental changes they cannot control, remains one of the most fascinating mysteries of the modern ocean. In the depths where oarfish normally dwell, changes imperceptible to human senses may ripple through the water long before the earth itself begins to shake. These ancient messengers, with their serpentine forms and otherworldly grace, continue to rise from the darkness, bearing warnings we are only beginning to understand. Off the coast of Australia, in the deep blue waters where great white sharks patrol ancient hunting grounds, marine biologists attached a sophisticated tracking device to a formidable predator they named Alpha. This 3-meter female great white was a perfect specimen, a mature apex predator equipped with the latest satellite tagging technology that would allow researchers to monitor her movements, depth, and body temperature as she roamed the vast Pacific. What happened next would shake the foundations of marine biology and introduce one of the most chilling mysteries ever recorded in the ocean's depths. For several months, Alpha behaved exactly as scientists expected. She cruised the coastal waters, diving to moderate depths to hunt seals and fish, her movements tracked by satellites as she followed the predictable patterns that have made great whites the most studied predators in the sea. Her data painted a picture of a successful hunter, perfectly adapted to her role as one of the ocean's most feared predators. But on December 4, 2003, everything changed in a way that defied all scientific understanding. The satellite tag recorded Alpha diving deeper than any great white had ever been observed to go. From her usual hunting depth of 20 to 30 meters, she plunged downward like a stone, descending through the water column at an impossible rate. The depth readings climbed past 100 meters, past 200, past 300. At 600 meters below the surface, in the crushing darkness of the deep ocean where great whites are never supposed to venture, Alpha's journey came to an abrupt and terrifying end. But it was not just the depth that shocked researchers. As Alpha descended into the abyss, her body temperature spiked dramatically. The tag recorded a temperature increase of 15 degrees Celsius in a matter of minutes, a change so rapid and extreme that it suggested only one possibility. Alpha had been consumed by something massive, something with an internal body temperature far higher than the frigid, deep ocean water. Something had swallowed one of the ocean's apex predators whole. Dr. Dave Riggs, the marine biologist leading the research project, stared at the data in disbelief. In decades of studying great white sharks, he had never seen anything like this. Great whites are not prey animals. They are the hunters, the apex predators that sit at the top of the marine food chain. The idea that something in the ocean could overpower and consume a 3-meter great white shark challenged everything the scientific community thought they knew about deep-sea ecosystems. The tag continued transmitting for several more hours, sending back data that only deepened the mystery. The temperature remained elevated, confirming that Alpha was indeed inside something with a warm internal environment. The depth readings showed continued movement, suggesting that whatever had consumed her was actively swimming through the deep ocean. Then, as suddenly as the incident had begun, the transmission stopped. The tag went silent, leaving researchers with more questions than answers. The scientific community struggled to explain what could have happened to Alpha. The most obvious suspect was a larger shark, perhaps a massive great white that dwarfed Alpha's 3-meter length. Great whites are known to exhibit cannibalistic behavior, with larger individuals occasionally preying on smaller ones. But the temperature data presented a problem. Sharks are cold-blooded creatures, and even the largest great white would have an internal temperature close to that of the surrounding water. The 15-degree temperature spike suggested something with a fundamentally different physiology. Another possibility was a giant squid or colossal squid, those legendary cephalopods that inhabit the deep ocean and engage in epic battles with sperm whales. These creatures are known to be formidable predators, with powerful beaks capable of cutting through flesh and bone. They also possess the size necessary to overpower a great white shark, but again, the temperature data posed a challenge. Squids, like sharks, are cold-blooded, and their internal temperature would not explain the dramatic thermal spike recorded by Alpha's tag. The most intriguing possibility, and the one that captured the imagination of both scientists and the public, was that Alpha had been consumed by a sperm whale. These marine mammals are warm-blooded, maintaining an internal body temperature of around 37 degrees Celsius regardless of the water temperature around them. A sperm whale's stomach would easily explain the temperature readings recorded by the tag. Moreover, sperm whales are known to dive to extreme depths, regularly descending to 600 meters or more to hunt for squid in the deep ocean. But even the sperm whale theory presented puzzles. While these whales are certainly large enough to consume a great white shark, they are not typically aggressive toward sharks. Their diet consists primarily of squid, and documented cases of sperm whales attacking sharks are extremely rare. The behavior would represent a dramatic departure from their normal feeding patterns, suggesting either an unusual individual or circumstances that forced the whale to abandon its typical prey preferences. Dr. Ingrid Visser, a marine biologist specializing in killer whale behavior, proposed another possibility that sent chills through the research community. She suggested that Alpha might have fallen victim to a massive killer whale, one of the ocean's most intelligent and adaptable predators. Killer whales are known to hunt great white sharks, using sophisticated techniques to flip the sharks upside down and induce a state of tonic immobility that renders them helpless. But the depth of the encounter, 600 meters below the surface, was far deeper than killer whales typically dive. The Alpha incident was not an isolated case. As researchers began combing through their databases, they discovered other instances of tagged sharks disappearing under mysterious circumstances. Some showed similar patterns of rapid descent followed by temperature spikes, while others simply vanished without explanation. The data suggested that something in the deep ocean was systematically hunting apex predators, creatures that were supposed to have no natural enemies in their adult form. One particularly disturbing case involved a 4-meter great white tagged off the coast of South Africa. Like Alpha, this shark was a mature predator, perfectly capable of defending itself against any known marine threat. But the tag data showed the same impossible pattern: a rapid descent to extreme depth, a dramatic temperature increase, and then silence. The incident occurred in waters over 2,000 meters deep, in an area where great whites had never been observed to venture. The pattern extended beyond great whites to other apex predators. Tiger sharks, bull sharks, and even massive hammerheads showed similar disappearances in tag data from around the world. Each incident followed the same chilling sequence: descent to unusual depth, temperature spike, and then nothing. It was as if something in the deep ocean was systematically removing the top predators from marine ecosystems. Sonar data from military submarines began to take on new significance as researchers searched for clues about Alpha's fate. Navy personnel reported detecting massive acoustic signatures in deep ocean waters, objects that moved too quickly and too purposefully to be geological features. Some contacts were estimated to be over 30 meters in length, far larger than any known marine animal. But every attempt to investigate these contacts ended in frustration, as the objects seemed to vanish whenever human technology approached. The mystery deepened when researchers examined the stomachs of sperm whales that had been found dead or dying in the months following the Alpha incident. Several contained the remains of large sharks, including species that should have been too large and aggressive for the whales to successfully hunt. The discovery suggested that sperm whales might be developing new hunting strategies, perhaps targeting sharks as an alternative food source when their preferred squid prey became scarce. But the most disturbing theory came from Dr. Peter Klimley, a leading shark researcher who had spent decades studying predator behavior. He proposed that the Alpha incident and similar disappearances might represent evidence of an unknown apex predator, something that inhabited the deepest parts of the ocean and emerged occasionally to hunt in shallower waters. This hypothetical creature would need to be massive, intelligent, and perfectly adapted to life in the abyss. The implications of such a predator were staggering. If something in the deep ocean was capable of hunting great white sharks, it would represent the true apex of marine food chains. Its existence would explain not only the Alpha incident, but also the mysterious scars found on sperm whales, the unexplained disappearances of other large marine animals, and the strange sonar contacts that continued to elude scientific investigation. Recent advances in deep-sea monitoring have begun to shed new light on the Alpha mystery. Autonomous underwater vehicles equipped with high-definition cameras and acoustic sensors now patrol the deep ocean, searching for signs of the unknown predator that might have claimed Alpha's life. Genetic analysis of whale stomach contents has revealed DNA from shark species that should not have been part of their diet, supporting the theory that something has disrupted the normal predator-prey relationships in the deep ocean. The Alpha incident remains one of the most compelling mysteries in marine biology, a reminder that the ocean still holds secrets that challenge our understanding of life on Earth. Somewhere in the crushing depths where no light penetrates, something moves through the darkness with the power to hunt the hunters, to prey upon the predators that we thought ruled the sea. Whether Alpha fell victim to a known predator exhibiting unusual behavior or became the prey of something vast and unknown that dwells in the deepest parts of our planet's oceans, her final moments represent a window into a world we are only beginning to understand. In the abyss where pressure builds and darkness reigns eternal, the rules of predation may be written by creatures we have never seen, following patterns we have never imagined. The ocean remembers Alpha's final dive, recorded in data that continues to puzzle scientists more than 2 decades later. Her journey into the darkness serves as a reminder that in the deepest places of our planet, we are still strangers, and the true masters of the deep remain hidden in shadows too profound for human eyes to penetrate. In the frigid waters of the Arctic Ocean, where ice floes drift like ancient monuments and the sun disappears for months at a time, lives a creature that defies one of biology's most fundamental rules. The Greenland shark, known scientifically as Somniosus microcephalus, moves through these polar seas like a living ghost from another era, its massive form gliding silently through water so cold it would kill most other large predators within minutes. But cold is not the Greenland shark's enemy. Cold is its secret to something that has eluded human understanding for centuries, the ability to seemingly stop time itself. These remarkable sharks can live for over 400 years, perhaps even 500, making them not just the longest-lived sharks, but among the oldest vertebrates on Earth. Individual Greenland sharks swimming in Arctic waters today may have been alive when Shakespeare was writing his plays, when the first European settlers were arriving in North America, when the scientific revolution was just beginning to change humanity's understanding of the natural world. They are living links to centuries past, witnesses to changes in the ocean that span human generations. The discovery of their extraordinary longevity began with a puzzle that marine biologists couldn't solve. Greenland sharks grow incredibly slowly, adding perhaps a centimeter to their length each year. When researchers began finding specimens that measured over 6 meters in length, the mathematics became staggering. If these sharks grew at a consistent rate throughout their lives, the largest individuals would need centuries to reach their observed size, but surely no shark could live that long. The assumption seemed impossible until scientists developed new techniques for determining the age of marine animals. Dr. Julius Nielsen, a marine biologist at the University of Copenhagen, pioneered the use of radiocarbon dating to determine the age of Greenland sharks. The technique relied on analyzing the carbon-14 content in the shark's eye lenses, which form during the earliest stages of life and remain unchanged throughout the animal's lifetime. When Nielsen and his team applied this method to a collection of Greenland shark specimens, the results were beyond anything they had imagined. One female, measuring just over 5 meters in length, was determined to be at least 272 years old, with a possible age range extending to over 400 years. Another specimen, a massive individual that had likely lived through the entire Industrial Revolution, showed carbon signatures suggesting it had been born sometime in the 1600s. These were not just old animals, they were living time machines, creatures whose lifespans dwarfed human civilization itself. The implications of such longevity were staggering. A Greenland shark alive today might remember the Arctic before climate change, before industrial pollution, before the massive changes that human activity has brought to the polar regions. These sharks have witnessed the rise and fall of ice ages, the shifting of ocean currents, the appearance and disappearance of other species. They are libraries of environmental history, their tissues storing information about the changing chemistry of the Arctic Ocean across centuries. But how do they do it? What allows the Greenland shark to essentially stop the aging process that limits every other large animal to a few decades of life? The answer lies in their extraordinary adaptations to life in the coldest waters on Earth. In the near-freezing temperatures of the Arctic Ocean, the Greenland shark's metabolism slows to an almost imperceptible crawl. Their heart rate drops to as low as 1 beat every 12 seconds. Their movements become so sluggish that they appear almost motionless, drifting through the water like underwater icebergs. This extreme cold adaptation comes with a price. Greenland sharks are among the slowest swimming sharks in the world, barely capable of bursts of speed that would seem leisurely to most other predators. Their maximum swimming speed has been measured at less than 3 kilometers per hour, slower than a human walking pace. Yet despite this apparent handicap, they have become apex predators in the Arctic ecosystem, proof that in the realm of evolutionary strategy, slow and steady truly can win the race. Their hunting strategy is as patient as their lifestyle. Greenland sharks are ambush predators, lying motionless in the water column until prey ventures within striking distance. Their slow metabolism means they can go months without feeding, waiting with the patience of geological time for the perfect opportunity. When that moment arrives, they strike with surprising efficiency, their powerful jaws capable of delivering a devastating bite despite their normally lethargic movements. The diet of Greenland sharks reveals the breadth of their hunting success. Stomach contents have revealed everything from fish and seals to polar bears and even other sharks. Some specimens have been found with the remains of reindeer in their stomachs, suggesting that these sharks sometimes feed on carcasses that have fallen through the ice. Their ability to consume such diverse prey speaks to their role as Arctic cleanup crew, removing carrion from the ecosystem while occasionally taking live prey. Perhaps most remarkably, their flesh contains high concentrations of trimethylamine oxide and other compounds that act as natural antifreeze, preventing ice crystals from forming in their tissues even in sub-zero water. But these same compounds are toxic to most other animals, including humans. The flesh of Greenland sharks contains neurotoxins that can cause symptoms similar to severe alcohol intoxication, leading to the Icelandic delicacy known as Hadal, which must be buried and fermented for months to break down the toxins before it can be safely consumed. The presence of these toxins raises fascinating questions about the shark's role in Arctic ecosystems. Are they protecting themselves from parasites and diseases that might otherwise limit their longevity? Do the toxins serve as a form of chemical warfare against competitors, or are they simply a byproduct of the unique biochemistry required to survive in such extreme conditions? Recent research has revealed that Greenland sharks possess other remarkable adaptations that may contribute to their extraordinary lifespan. Their tissues show unusually high levels of antioxidants, chemicals that prevent the cellular damage associated with aging in other animals. Their DNA repair mechanisms appear to be exceptionally efficient, constantly fixing the molecular damage that accumulates over time in normal organisms. Some scientists believe that studying these sharks could unlock secrets relevant to human aging and longevity research. The reproductive biology of Greenland sharks adds another layer to their temporal mystery. Females do not reach sexual maturity until they are at least 150 years old, possibly much older. This means that a shark born today would not be capable of reproduction until well into the 22nd century. Their gestation period is thought to last several years, and they may only reproduce a few times during their centuries-long lives. This incredibly slow reproductive cycle makes them particularly vulnerable to overfishing and environmental changes. The navigation abilities of these ancient sharks present yet another puzzle. How do creatures that live for centuries navigate the changing Arctic landscape? The magnetic field of the Earth shifts over time, ice coverage changes with climate cycles, and ocean currents can alter their patterns across decades. Yet Greenland sharks somehow maintain their ability to find food, mates, and suitable habitat across their impossibly long lifespans. Some researchers have proposed that Greenland sharks possess a form of cultural memory, learning and remembering environmental patterns across centuries. Young sharks might learn migration routes and feeding strategies from individuals that have been alive for hundreds of years, creating a repository of ecological knowledge that spans human history. If this is true, the loss of old individuals could represent the destruction of irreplaceable environmental information. The study of Greenland sharks has also revealed the profound impact of human activity on long-lived marine species. Pollutants that entered the Arctic Ocean decades ago are still present in the tissues of these sharks, creating a timeline of industrial contamination that spans the better part of a century. Heavy metals, pesticides, and other chemicals that were banned long ago continue to circulate in the Arctic ecosystem, concentrated in the bodies of its longest-lived inhabitants. Climate change poses perhaps the greatest threat to these remarkable creatures. As Arctic waters warm, the delicate balance of cold adaptation that allows Greenland sharks to live for centuries may be disrupted. Higher temperatures could accelerate their metabolism, potentially shortening their lifespans and disrupting reproductive cycles that have remained unchanged for millennia. The loss of sea ice could alter food webs and migration patterns that these sharks have followed for centuries. The conservation implications are staggering. When a Greenland shark dies, whether from natural causes or human activity, the loss represents not just an individual animal, but potentially centuries of accumulated experience and genetic adaptation. A shark killed today might have contained information about Arctic conditions from before the Industrial Revolution, knowledge that could be crucial for understanding and predicting environmental changes. Modern tagging studies are beginning to reveal the daily lives of these ancient mariners. Satellite tags show that they make long migrations across the Arctic basin, following routes that may have been established centuries ago. Some individuals appear to have regular territories that they patrol over decades, returning to the same areas with the reliability of clockwork despite the changing ice conditions above. The Greenland shark represents something profound about life itself, the possibility that with the right adaptations, consciousness can persist across timescales that dwarf human experience. These creatures have mastered the art of survival through patience, through slowing life down to the point where centuries pass like seasons. They remind us that in the grand scheme of biological time, our human lifespans are mere flickers, while in the cold darkness of the Arctic depths, ancient minds continue their slow dance through time. In the deep, time itself seems to change. Some creatures do not just survive the passing centuries, they drift through them like living monuments to the power of adaptation, carrying within their ancient cells the secrets of longevity that science is only beginning to understand. In the perpetual twilight of the ocean's oxygen minimum zones, where most life cannot survive and darkness reigns eternal, dwells a creature so ancient and so perfectly adapted to its hostile environment that it seems to exist outside the normal flow of evolutionary time. The vampire squid, despite its ominous name, is neither vampire nor squid, but something far more remarkable, a living fossil that has remained virtually unchanged for over 300 million years, a survivor from an era when the oceans themselves were fundamentally different from the waters we know today. Vampiroteuthis infernalis, literally translated as the vampire squid from hell, inhabits a realm that most marine life cannot even visit, let alone call home. The oxygen minimum zones where it thrives are areas of the deep ocean where dissolved oxygen levels drop so low that fish suffocate and most invertebrates simply cannot function. These zones, typically found between 600 and 900 meters below the surface, represent some of the most extreme environments on our planet, places where the chemistry of life itself operates at the very edge of possibility. Yet in this seemingly hostile realm, the vampire squid has not merely survived but flourished. Its deep red to black coloration makes it nearly invisible in the perpetual darkness. while its unique anatomy represents a masterpiece of adaptation to low oxygen conditions. Unlike true squids or octopuses, the vampire squid possesses 8 arms lined with fleshy spines rather than suckers, and 2 additional sensory filaments that can extend to twice the length of its body, creating an alien silhouette that seems more suited to science fiction than marine biology. The discovery of the vampire squid's true nature began with specimens brought up from the deep by early deep-sea expeditions. Marine biologist Carl Chun first described the species in 1903, but it took decades of research to understand that this creature represented something unprecedented in the animal kingdom. Initial classifications attempted to place it among either the squids or the octopuses, but careful anatomical study revealed that it belonged to neither group. Instead, it represented the sole surviving member of an ancient lineage, the order Vampiromorphida, that had branched off from other cephalopods hundreds of millions of years ago. Dr. Henk Jan Hoving, a deep-sea biologist who has spent years studying vampire squids, describes them as evolutionary time capsules. Their anatomy preserves features that existed in ancient oceans when oxygen levels were much lower than they are today. During the Paleozoic era, vast areas of the world's oceans experienced oxygen depletion similar to the modern zones where vampire squids thrive. As ocean chemistry changed and oxygen levels rose, most life forms adapted to the new conditions or went extinct. But the vampire squid found refuge in the remaining low oxygen zones, islands of ancient ocean chemistry where it could continue its timeless existence. The feeding strategy of the vampire squid is as unique as its anatomy. While its relatives are active predators that hunt living prey, the vampire squid has evolved to be a scavenger of the deep, feeding on marine snow, the constant rain of organic particles that drifts down from the productive surface waters above. This diet consists of dead plankton, fecal pellets, mucus houses from tiny organisms, and other organic debris that would be ignored by most predators. It is a humble menu, but one that provides a steady food source in an environment where encounters with living prey are rare. The vampire squid's method of collecting this marine snow is equally remarkable. Its long sensory filaments act like fishing lines, extending into the water column to capture particles of organic matter. These filaments are covered with tiny sticky cells that trap the marine snow, which is then drawn back to the mouth using specialized arm movements. The entire feeding process is conducted with minimal energy expenditure, perfectly suited to an environment where every calorie must be conserved. Perhaps most fascinating is the vampire squid's response to threats. When disturbed, it can turn itself inside out, inverting its body so that its arms surround its head like a protective cloak, with the spines on its arms pointing outward to deter predators. This defensive posture, combined with bioluminescent photophores that can create confusing light displays, makes the vampire squid one of the most otherworldly sights in the deep ocean. The creature can also jettison clouds of bioluminescent mucus, creating a glowing smokescreen that confuses predators while it escapes into the darkness. The bioluminescence of the vampire squid represents another marvel of deep-sea adaptation. Its photophores can produce blue light on command, and the pattern and intensity of these lights can be controlled with remarkable precision. Some displays appear to be defensive, designed to startle or confuse predators, while others may serve as communication signals in the vast darkness of the deep ocean. The vampire squid can even produce a spectacular fireworks display, ejecting luminous particles that create expanding clouds of blue light. The reproductive biology of vampire squids reflects their extreme environment and ancient lineage. They reproduce multiple times throughout their lives, unlike most other cephalopods which die after their first reproductive event. This strategy makes sense in an environment where opportunities for reproduction may be rare and unpredictable. Females carry their eggs for over a year, the longest brooding period known for any cephalopod, carefully protecting their developing offspring in the hostile depths. Recent research has revealed that vampire squids play a crucial role in deep ocean carbon cycling. Their diet of marine snow makes them important processors of organic matter that would otherwise decompose slowly in the low oxygen environment. By consuming this material and packaging it into fecal pellets, they help transport carbon to even deeper parts of the ocean, contributing to the global carbon cycle in ways that scientists are only beginning to understand. The study of vampire squids has been revolutionized by advances in deep-sea technology. remotely operated vehicles equipped with high-definition cameras have captured stunning footage of these creatures in their natural habitat, revealing behaviors that were impossible to observe in laboratory settings. These observations have shown vampire squids moving through their environment with graceful efficiency, their unique anatomy perfectly suited to life in the oxygen-depleted depths. Dr. Bruce Robertson, a senior scientist at the Monterey Bay Aquarium Research Institute, has observed vampire squids during thousands of deep-sea dives. His research has revealed that these creatures are far more active and behaviorally complex than their energy-conserving lifestyle might suggest. They have been observed engaging in what appears to be social behavior, with multiple individuals sometimes found in close proximity, suggesting that even in the sparse environment of the oxygen minimum zones, vampire squids may form communities. The conservation implications of vampire squid research extend far beyond the creatures themselves. The oxygen minimum zones they inhabit are expanding due to climate change, as warming ocean temperatures reduce the water's ability to hold dissolved oxygen. While this might seem beneficial for vampire squids, the reality is more complex. The expansion of these zones is happening too rapidly for most ecosystems to adapt, potentially disrupting the delicate food webs that vampire squids depend upon. Moreover, the ancient nature of vampire squids makes them living indicators of ocean health. Changes in their populations or behavior could signal fundamental shifts in deep ocean chemistry that might affect marine ecosystems worldwide. As some of the few large animals capable of thriving in low oxygen conditions, they serve as sentinels for a possible future where much of the ocean becomes uninhabitable for most marine life. The vampire squid's resistance to environmental stress has attracted the attention of researchers studying extremophile organisms. Their ability to survive in conditions that would kill most other animals makes them valuable models for understanding the limits of life itself. Some scientists speculate that similar organisms might exist in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus, where liquid water exists beneath thick ice shells in environments that might resemble Earth's oxygen minimum zones. The metabolic adaptations of vampire squids continue to surprise researchers. Their extremely low metabolic rate allows them to survive on minimal food intake, but they can rapidly increase their activity when necessary. This flexibility suggests sophisticated physiological control mechanisms that allow them to fine-tune their energy usage based on environmental conditions and food availability. Modern genetic analysis has confirmed the vampire squid's ancient origins and unique evolutionary position. DNA studies reveal that they diverged from other cephalopods before the split between squids and octopuses, making them a crucial link for understanding the evolution of intelligence in marine invertebrates. Despite their simple lifestyle, vampire squids possess complex nervous systems and demonstrate problem-solving abilities that hint at cognitive capabilities shaped by hundreds of millions of years of deep-sea survival. The vampire squid represents more than just an evolutionary curiosity. It embodies the power of adaptation, showing how life can persist in even the most challenging environments by finding novel solutions to environmental pressures. In a world increasingly concerned about habitat destruction and species extinction, the vampire squid offers hope that life, given enough time and the right conditions, can find ways to endure. A creature not of nightmares but of endurance, the vampire squid belongs to a world most organisms cannot even breathe in. It reminds us that the boundaries of the possible are far broader than we imagine, and that in the deepest places of our planet, ancient forms of life continue their patient dance through time, carrying within their cells the secrets of survival across geological ages. In the perpetual darkness of the deep ocean, where sunlight has never penetrated and the weight of water above would crush any surface dweller, an extraordinary phenomenon illuminates the abyss. Here, in this alien realm, over 80% of all creatures have evolved the ability to create their own light, transforming the deep sea into a living constellation of biological stars. This is the bioluminescent labyrinth, a world where light itself has become a language, a weapon, a lure, and a shield in the endless struggle for survival. The chemistry of bioluminescence is one of nature's most elegant solutions to the problem of communication in absolute darkness. Deep-sea creatures produce light through a chemical reaction involving luciferin, a light-emitting compound, and luciferase, an enzyme that catalyzes the reaction. When these molecules combine in the presence of oxygen, they create what is essentially cold light, a form of illumination so efficient that nearly 100% of the energy is converted to light with virtually no heat production. It is a biological technology that surpasses any human invention for pure efficiency. But in the deep ocean, bioluminescence is far more than just a source of illumination. It has evolved into a sophisticated communication system with a complexity that rivals human language. Different species have developed unique light signatures, patterns of flashes that serve as identification markers in the darkness. Like fireflies on a summer evening, deep-sea creatures use specific sequences of blinks and glows to find members of their own species in the vast emptiness of the abyss. Dr. Edith Widder, a marine biologist who has spent decades studying bioluminescence, describes the deep ocean as the world's largest theater, where every creature is both performer and audience in an endless light show. Her research has revealed that bioluminescent displays in the deep sea are far more varied and sophisticated than scientists once believed. Some creatures produce steady glows, others create rapid flashing sequences, and still others can modulate their light like underwater disco balls, creating patterns that pulse and swirl through the water. The lanternfish, one of the most abundant creatures in the deep ocean, demonstrates the complexity of bioluminescent communication. These small fish possess multiple rows of photophores, specialized light-producing organs, arranged in species-specific patterns along their bodies. Each species has its own unique arrangement of lights, creating a biological barcode that allows individuals to identify potential mates or competitors, even in complete darkness. The patterns are so distinctive that marine biologists can identify different lanternfish species simply by photographing their light displays. But bioluminescence in the deep sea serves purposes far beyond simple identification. For many creatures, light has become the ultimate hunting tool. The anglerfish, perhaps the most famous of the deep-sea predators, uses a bioluminescent lure to attract prey in the darkness. The light, produced by symbiotic bacteria living in a specialized organ, dangles in front of the fish's massive jaws like an underwater fishing lure. Small fish and crustaceans, drawn to what appears to be food or a potential mate, swim directly into the anglerfish's waiting mouth. The deep sea bristles with such predatory light displays. Viperfish possess photophores along their bodies that can be flashed in sequence, creating the illusion of movement that attracts curious prey. Some species of squid can produce traveling waves of light across their skin, mesmerizing potential victims before striking with their powerful tentacles. The vampire squid, when threatened, can eject clouds of bioluminescent mucus, creating a glowing smokescreen that confuses predators while it escapes into the darkness. Perhaps most remarkably, some deep-sea creatures have evolved the ability to mimic the bioluminescent signals of other species. Certain deep-sea jellies can replicate the light patterns of small fish, luring larger predators within range of their stinging tentacles. This biological mimicry represents a form of underwater deception that would make any spy envious, as creatures literally steal the light languages of other species to achieve their own ends. The Atolla jellyfish has developed one of the most spectacular defensive light displays in the ocean. When attacked, it creates what researchers call a burglar alarm, a spinning crown of blue light that spreads outward like an underwater firework. This brilliant display serves a dual purpose. It startles immediate predators while potentially attracting even larger predators that might attack the atolla's assailant. It is a desperate strategy that turns the deep sea's food web into a weapon of last resort. Color plays a crucial role in the bioluminescent labyrinth, even though the deep ocean is essentially a monochrome environment. Most bioluminescent creatures produce blue or blue-green light, wavelengths that travel furthest through seawater and are most efficiently detected by the eyes of deep-sea animals. However, some species have evolved to produce different colors, creating private communication channels that other creatures cannot easily intercept or interpret. The deep-sea dragonfish represents one of the most sophisticated users of colored bioluminescence. While most of its photophores produce the standard blue light, It also possesses special organs that can generate red light, a color that most deep-sea creatures cannot see. This gives the dragonfish a significant advantage, allowing it to illuminate potential prey with red light without alerting them to its presence. It is like having infrared night vision goggles in a world where most creatures are colorblind. The temporal patterns of bioluminescent displays add another layer of complexity to deep-sea communication. Some creatures produce rapid stroboscopic flashes that last only milliseconds, while others maintain steady glows for hours at a time. The timing of these displays often corresponds to specific behaviors or environmental conditions. Many deep-sea animals increase their bioluminescent activity during certain phases of the moon, suggesting that even in the perpetual darkness of the abyss, creatures remain connected to celestial rhythms. Research has revealed that bioluminescent displays can be remarkably energy expensive for deep-sea creatures, particularly in an environment where food is often scarce. This suggests that the evolutionary pressure to communicate effectively in the darkness must be enormous, driving creatures to invest significant metabolic resources in their light-producing capabilities. The fact that so many deep-sea species have independently evolved bioluminescence demonstrates its crucial importance for survival in the abyss. The study of deep-sea bioluminescence has been revolutionized by advances in underwater technology. Ultra-sensitive cameras capable of detecting even the faintest biological light have revealed a level of activity in the deep ocean that was previously invisible to science. What once appeared to be a relatively quiet environment has been shown to be alive with constant light-based communication, a 24-hour light show that never stops. Dr. Stephen Haddock, a researcher at the Monterey Bay Aquarium Research Institute, has documented hundreds of different bioluminescent displays during deep-sea dives. His work has shown that bioluminescence is not just common in the deep ocean, but is actually the dominant form of sensory communication. In an environment where sound travels well but can attract unwanted attention, and where chemical signals disperse slowly in the currents, light has become the preferred medium for most forms of biological interaction. The ecological implications of bioluminescence extend far beyond individual species interactions. The daily migration of bioluminescent organisms from the deep ocean to surface waters represents one of the largest movements of biomass on Earth. As night falls, billions of light-producing creatures rise from the depths to feed in surface waters, creating what marine biologists call the deep scattering layer. This massive vertical migration, guided by bioluminescent signals, redistributes nutrients and energy throughout the ocean's water column. Climate change and human activities pose new challenges to the bioluminescent labyrinth. Ocean acidification, caused by increased carbon dioxide absorption, can interfere with the chemical processes that produce bioluminescence. Pollution, particularly light pollution from coastal cities, can disrupt the migration patterns of bioluminescent organisms that rely on natural light cues. Deep-sea mining and bottom trawling destroy the seafloor habitats where many bioluminescent creatures live and reproduce. The potential applications of bioluminescence research extend far beyond marine biology. Scientists are studying the chemical mechanisms of biological light production to develop new forms of sustainable lighting, medical imaging techniques, and environmental monitoring systems. The efficiency of bioluminescent reactions has inspired research into organic light-emitting diodes and other green technologies that could revolutionize human lighting systems. Recent discoveries have revealed that bioluminescence may be even more widespread in the deep ocean than previously thought. Genetic analysis has identified the genes responsible for light production in species that were not previously known to be bioluminescent, suggesting that the ability to produce light may be nearly universal among deep-sea creatures. Some researchers now believe that bioluminescence may have evolved independently in the ocean hundreds of times, making it one of the most successful adaptations in the history of life on Earth. The symbiotic relationships that many deep-sea creatures maintain with bioluminescent bacteria add another dimension to the labyrinth of light. These partnerships represent some of the most intimate collaborations in nature, with bacteria providing light in exchange for nutrients and protection. The bacteria themselves can be passed from parent to offspring, creating lineages of light that span generations. Some creatures even cultivate multiple species of bacteria, each producing different colors or intensities of light for specific purposes. The future of bioluminescence research holds promise for unlocking even more secrets of the deep ocean's light-based ecosystem. Advanced submersibles equipped with spectral analysis equipment can now identify the specific wavelengths and chemical signatures of different bioluminescent displays, creating detailed maps of the deep sea's light landscape. Autonomous underwater vehicles are being programmed to follow bioluminescent signals, potentially revealing migration patterns and behaviors that have never been observed. Down here, light does not just illuminate, it deceives, communicates, and sometimes hypnotizes. The bioluminescent labyrinth represents one of evolution's most beautiful solutions to the challenge of life in perpetual darkness, a world where creatures have learned to paint with light itself, creating masterpieces of biological art that dance through the abyss in patterns we are only beginning to understand. At the very bottom of our planet's oceans, in trenches so deep that they could swallow Mount Everest and still have room for more, life persists in forms so alien that they challenge our understanding of what is biologically possible. Here, in the Hadal zone, where pressures exceed 1,000 times that at sea level and darkness is absolute, swim creatures that exist at the very edge of life itself. The Hadal snailfish, ghostly inhabitants of these deepest places, represent life's ultimate triumph over seemingly impossible conditions. The Hadal zone, named after Hades, the ancient Greek underworld, begins at depths of 6,000 meters and extends to the deepest points on Earth, over 11,000 meters down in places like the Mariana Trench. At these depths, the pressure is so intense that it would instantly crush any surface-dwelling creature, compacting bones to powder and collapsing air-filled organs in milliseconds. Yet the Hadal snailfish glide through this hostile environment with ethereal grace, their translucent bodies perfectly adapted to conditions that represent the absolute limits of where complex life can exist. Dr. Alan Jameson, a deep-sea biologist who has dedicated his career to exploring the Hadal zone, describes these creatures as living contradictions. They appear impossibly delicate, with gelatinous bodies so transparent that their internal organs are clearly visible through their skin, yet they thrive in an environment that would destroy steel. Their movements are slow and dreamlike, drifting through the water like underwater ghosts, but they are actually sophisticated predators, perfectly adapted to their extreme habitat. The first Hadal snailfish were discovered during deep-sea expeditions in the 1950s, but it was not until the development of advanced deep-diving technology that scientists began to understand the true scope of their remarkable adaptations. These fish possess no swim bladders, the gas-filled organs that most fish use to control their buoyancy. In the crushing depths of the Hadal zone, any gas-filled structure would be compressed to nothing, so Hadal snailfish have evolved alternative solutions to the problem of neutral buoyancy. Instead of gas, these remarkable creatures use specialized proteins and osmolytes to maintain their body structure under extreme pressure. Their cells contain high concentrations of trimethylamine oxide, a compound that acts as a pressure protectant, preventing the crushing forces from destroying cellular structures. This adaptation allows their proteins to function normally even under pressures that would denature the proteins of surface-dwelling organisms within seconds. The anatomy of Hadal snailfish reflects their adaptation to life at the bottom of the world. Their skeletons are largely cartilaginous rather than bony, providing flexibility under pressure while maintaining structural integrity. Their bodies are elongated and eel-like, allowing them to navigate through the complex topography of trench floors where fallen debris from the surface creates underwater mountains and valleys. Their fins are enlarged and fan-like, perfect for maneuvering in the slow-motion world of the deep trenches. Perhaps most remarkably, Hadal snailfish have no pigmentation, appearing as ghostly, transparent forms drifting through the absolute darkness of their environment. This transparency is not merely cosmetic but serves important biological functions. In an environment where food is incredibly scarce, the energy saved by not producing pigments can mean the difference between survival and starvation. Additionally, their transparent bodies make them nearly invisible to the few predators that share their extreme habitat. The feeding ecology of Hadal snailfish reveals the challenges of life in the Earth's deepest places. Food in the Hadal zone comes primarily from marine snow, the constant rain of organic particles that drifts down from the productive surface waters far above. By the time this organic matter reaches trench depths, it has been picked over by countless organisms during its long journey downward. What finally reaches the Hadal zone is largely indigestible cellulose and other refractory materials that most organisms cannot process. Hadal snailfish have evolved remarkable digestive capabilities to extract nutrition from this extremely poor quality food source. Their digestive systems are elongated and highly efficient, capable of breaking down cellulose and other complex organic compounds that other fish cannot digest. They also practice a form of dietary opportunism, feeding on any organic matter they encounter, including the occasional carcass of larger animals that sinks to the trench floor. The reproductive biology of Hadal snailfish presents another set of extraordinary adaptations. In an environment where encounters between individuals are rare due to the vast empty spaces of the trenches, these fish have evolved strategies to maximize their reproductive success when mating opportunities do arise. Some species are thought to be hermaphroditic, possessing both male and female reproductive organs, which doubles their chances of successful reproduction when they encounter another individual. Dr. Mackenzie Geringer, a researcher who has studied Hadal snailfish extensively, has discovered that different trench systems around the world harbor distinct species of these remarkable fish. The Mariana Trench, the Japan Trench, the Peru-Chile Trench, and the Kermadec Trench each possess their own endemic species of Hadal snailfish, suggesting that these trenches act as isolated evolutionary laboratories where life has independently adapted to extreme conditions. The discovery process for Hadal snailfish requires some of the most advanced technology available to marine science. These creatures live at depths that can only be reached by specially designed deep-sea landers, unmanned vehicles that are dropped from the surface and sink to the ocean floor under their own weight. These landers are equipped with cameras, sampling equipment, and specialized pressure chambers that allow specimens to be brought to the surface for study. One of the most challenging aspects of studying Hadal snailfish is that they cannot survive decompression. When brought to the surface, the dramatic pressure change causes their bodies to essentially dissolve, their pressure-adapted cellular structures breaking down as the protective force of the deep is removed. This means that most research must be conducted using preserved specimens or through video observations made at depth. Recent technological advances have begun to overcome some of these limitations. Ultra-high pressure chambers that can maintain trench-level pressures during transport to the surface have allowed scientists to keep Hadal specimens alive long enough for detailed physiological studies. These experiments have revealed that Hadal snailfish possess metabolic rates that are incredibly slow even by deep-sea standards, conserving energy in an environment where every calorie must be carefully managed. The genetic adaptations of Hadal snailfish provide insights into the molecular mechanisms that allow life to exist under extreme pressure. Their DNA contains genes for specialized enzymes that function only under high pressure conditions. These pressure-adapted enzymes are so specialized that they actually cease to function properly if the pressure is reduced, explaining why these fish cannot survive decompression. Climate change presents unique challenges for Hadal snailfish and other trench-dwelling organisms. While the deep trenches are largely isolated from surface conditions, they are not immune to global changes. Ocean acidification, caused by increased carbon dioxide absorption, reaches even the deepest trenches, potentially affecting the chemistry of the specialized proteins that allow Hadal snailfish to survive under pressure. The study of Hadal snailfish has implications that extend far beyond marine biology. These creatures represent some of the most pressure-adapted life forms on Earth, and understanding their biology could provide insights relevant to astrobiology. The conditions in deep ocean trenches are similar in some ways to those that might exist in the subsurface oceans of icy moons like Europa and Enceladus, making Hadal organisms potential models for extraterrestrial life. The ecosystem of the Hadal zone, with Hadal snailfish as its most visible representatives, challenges traditional concepts of biological productivity and energy flow. These trenches, once thought to be biological deserts, are now known to support complex food webs based on chemosynthesis and the efficient recycling of organic matter. Hadal snailfish play a crucial role in these ecosystems, serving as both predators and prey in food webs that operate on entirely different principles from those at the surface. Conservation of Hadal ecosystems presents unique challenges. These environments are so remote and difficult to access that we are only beginning to understand their biological diversity and ecological importance. yet they are already threatened by human activities, including deep-sea mining, pollution, and the disposal of radioactive waste in ocean trenches. The loss of Hadal species like the snailfish would represent the extinction of evolutionary adaptations that took millions of years to develop and could never be replaced. The ongoing exploration of Hadal environments continues to reveal new species of snailfish and other adapted organisms. Each expedition to the deep trenches discovers new forms of life that push the boundaries of what we thought was biologically possible. These discoveries remind us that even in the most extreme environments on our planet, life finds ways to not just survive, but to thrive in forms of stunning beauty and remarkable adaptation. The deeper we look, the more we find. And at the very bottom, in the crushing darkness of the Earth's deepest places, they are already waiting, these ghosts of the trenches, proof that life's creativity knows no bounds, and that even in the most impossible places, evolution continues to write new chapters in the story of life on Earth. In the deepest reaches of our oceans, where time seems to move differently and the very concept of aging becomes fluid, swim creatures whose life stories read like impossible fairy tales. Deep-sea eels, those serpentine inhabitants of the abyss, live lives that span centuries while undergoing transformations so dramatic they seem to violate the basic rules of biology. These are creatures that grow backwards, change gender at will, and embark on migrations so mysterious that science has only glimpsed fragments of their true journeys through time and space. The European eel, Anguilla anguilla, begins its life as a tiny transparent larva no larger than a willow leaf, drifting through the deep Atlantic Ocean in what may be the most extraordinary migration in the animal kingdom. Born somewhere in the vast expanse of the Sargasso Sea, these larvae embark on a journey that can take decades to complete, riding ocean currents across thousands of kilometers while undergoing a transformation that would make any shapeshifter envious. What makes this migration so remarkable is not just its distance, but its temporal dimension. These eel larvae, known as leptocephali, do not simply swim from point A to point B. Instead, they exist in a state of suspended development, remaining as transparent, leaf-like creatures for years or even decades as they drift through the deep ocean. During this time, they grow larger but do not mature, existing in a biological limbo that allows them to survive in the nutrient-poor waters of the open ocean. Dr. Katsumi Tsukamoto, a Japanese marine biologist who has devoted his career to understanding eel biology, describes these creatures as living time capsules. His research has revealed that the larval stage of deep-sea eels can last far longer than previously imagined, with some individuals remaining in their transparent form for over a century. This extended larval period challenges everything scientists thought they knew about fish development and the relationship between age and growth in marine animals. The transformation that eventually occurs when eel larvae approach their destination is one of nature's most dramatic metamorphoses. The transparent, leaf-like leptocephalus suddenly begins to shrink, losing mass as it transforms into a glass eel, a tiny, translucent version of its adult form. This reverse growth, where an animal actually becomes smaller as it develops, is virtually unique in the animal kingdom and represents a biological puzzle that scientists are still struggling to understand. But the mysteries of eel biology extend far beyond their larval stage. Adult European eels can live for over a century in freshwater rivers and lakes, growing slowly but steadily throughout their extended lives. Some specimens have been documented living for over 150 years, making them among the longest-lived vertebrates on Earth. During this time, they undergo subtle but continuous changes, their bodies preparing for a final transformation that will define the last chapter of their remarkable lives. The American eel, Anguilla rostrata, shares this pattern of extraordinary longevity and mysterious life cycles. These creatures spend decades in North American rivers and coastal waters, growing to impressive sizes while remaining sexually immature. Like their European cousins, they seem to exist outside the normal constraints of biological time, aging at a pace that defies conventional understanding of vertebrate life cycles. Recent research by Dr. Donald Jellyman in New Zealand has revealed that deep-sea eels possess cellular mechanisms that appear to slow the aging process to an almost supernatural degree. Their telomeres, the protective caps on chromosomes that typically shorten with age, show minimal degradation even in century-old specimens. Their cells exhibit remarkable resistance to the oxidative damage that causes aging in most other animals, suggesting that these creatures have unlocked biological secrets that could revolutionize our understanding of longevity. The feeding ecology of deep-sea eels during their extended larval phase presents another biological enigma. These transparent creatures feed on marine snow, the organic particles that drift down from surface waters, but their metabolism is so slow that they require only minute amounts of food to survive. They exist in a state of near starvation that would kill most other animals, yet they continue to grow and develop, albeit at an almost imperceptible pace. Some researchers have proposed that deep-sea eel larvae enter a form of biological hibernation during their extended oceanic phase, slowing their metabolism to such a degree that they exist in a state suspended between life and death. This would explain their ability to survive for decades in the nutrient-poor waters of the open ocean while continuing their slow migration toward their eventual adult habitat. The reproductive behavior of deep-sea eels represents the ultimate mystery in marine biology. After spending decades or even centuries growing to maturity in freshwater environments, adult eels undergo a final transformation that prepares them for their spawning migration. Their digestive systems atrophy, their eyes enlarge, and their skin changes color as they prepare for a journey from which they will never return. The spawning grounds of European and American eels in the Sargasso Sea remain one of the ocean's greatest unsolved mysteries. Despite decades of research and numerous expeditions, no scientist has ever observed these eels spawning in the wild. The spawning grounds are inferred from the distribution of larvae, but the actual process of reproduction remains hidden in the deep waters of the Atlantic, protected by darkness and distance from human observation. Dr. Michael Miller, who has studied eel migrations for over 30 years, believes that the spawning behavior of these creatures may involve depths and locations that human technology has never reached. Recent oceanographic research has revealed deep water features in the Sargasso Sea that could serve as spawning grounds, including underwater mountains and thermal vents that create unique environmental conditions. The navigation abilities of deep-sea eels during their spawning migrations present another layer of mystery. How do creatures that have spent decades in freshwater rivers find their way across thousands of kilometers of open ocean to specific spawning grounds? Some researchers believe they use magnetic navigation, following the Earth's magnetic field lines like living compasses. Others suggest they may follow chemical gradients or use astronomical cues invisible to human perception. The death phase of deep-sea eels adds a final poignant chapter to their extraordinary life stories. After spawning, these ancient creatures die, their bodies sinking into the deep ocean where they become food for the very ecosystems that supported their larval development decades earlier. This completes a biological cycle that spans continents and centuries, connecting freshwater rivers to deep ocean basins in a pattern of connectivity that scientists are only beginning to understand. Climate change poses unprecedented threats to these ancient migration patterns. Ocean warming is altering current systems that eel larvae depend on for their transoceanic journeys. Changes in ocean chemistry are affecting the marine snow that sustains them during their extended larval phase. The construction of dams and other barriers in rivers is preventing adult eels from reaching their traditional growing habitats, disrupting life cycles that have remained unchanged for millions of years. The conservation implications are staggering. European eel populations have declined by over 90% in recent decades, and American eels are following a similar trajectory. The loss of these species would represent the extinction of some of the most remarkable life histories in the animal kingdom, creatures whose very existence challenges our understanding of what is biologically possible. Recent genetic studies have revealed that different populations of deep-sea eels may follow entirely different migration routes and life history strategies. Some larvae may take direct routes to their destination, while others embark on circuitous journeys that can last for over a century. This diversity of life strategies within a single species suggests that eel biology is even more complex than previously imagined. The study of deep-sea eels has implications that extend far beyond marine biology. Their extraordinary longevity and resistance to aging have attracted the attention of researchers studying human aging and disease. The cellular mechanisms that allow these creatures to live for centuries while maintaining their health and vitality could provide insights relevant to medical research and the development of anti-aging therapies. Advances in deep-sea tracking technology are beginning to shed new light on eel migrations. Satellite tags and acoustic transmitters are revealing previously unknown aspects of their behavior, including the depths they dive to during their spawning migrations and the routes they follow across ocean basins. Each new discovery adds another piece to the puzzle of eel biology while revealing just how much we still do not understand. The cultural significance of eels in human societies around the world reflects their mysterious nature. In many cultures, eels are associated with transformation, longevity, and the connection between different worlds. These cultural associations may be more scientifically accurate than previously realized, given what we now know about the extraordinary life cycles of these creatures. Modern aquaculture attempts to breed eels in captivity have largely failed, despite decades of research and millions of dollars in investment. The complex life cycle requirements of these creatures, including their need for specific ocean conditions during their larval phase, make them nearly impossible to reproduce artificially. This adds urgency to conservation efforts, as wild populations cannot be easily replaced once they are lost. In the dark depths where eel larvae drift through their extended childhood, time itself seems to change. Age becomes a fluid concept, and the normal rules of growth and development bend to accommodate life strategies that span geological timescales. These creatures remind us that biology is far more flexible and mysterious than our human-centered perspective usually allows us to imagine. Some creatures do not just survive the passing decades, they drift through them like living symbols of endurance, carrying within their ancient cells the secrets of time itself, and reminding us that in the deepest places of our planet, the impossible becomes routine and time flows like a slow river through the darkness. In these crushing depths, we have encountered giants that leave scars on whales but remain forever unseen. Singers whose lonely calls echo through decades of solitude, and creatures known only in death, despite their massive presence in life. We have witnessed the impossible. Sharks that live for centuries, squids that survive by turning themselves inside out, and fish that exist in a state of suspended animation for longer than human civilizations endure. The ocean remembers everything. In the tissues of ancient Greenland sharks swim chemical signatures from centuries past, records of a world before industry, before pollution, before the great acceleration of human impact on the planet. These living archives carry within their cells the memory of Arctic waters as they existed when the first European explorers were just beginning to map the coastlines of distant continents. Their flesh contains the chemical fingerprints of volcanic eruptions, meteor impacts, and climate shifts that occurred long before humans understood such events were even possible. In the genes of vampire squids lie the blueprints for survival strategies perfected over 300 million years, adaptations so successful that evolution has left them unchanged while entire geological eras passed overhead. These creatures have witnessed the rise and fall of ice ages, the movement of continents, the mass extinctions that reshaped life on Earth. They are living fossils in the truest sense, carrying forward into our modern world the solutions to survival challenges that were ancient when the first dinosaurs walked the Earth. Each bioluminescent flash in the darkness carries information we are only beginning to decode, conversations in languages of light that have been evolving since before complex life existed on land. These optical communication systems represent millions of years of refinement, biological technologies that surpass our most sophisticated electronics in their efficiency and complexity. The deep-sea creatures that produce these lights are engaging in conversations that span vast distances and perhaps vast timescales, exchanging information about food sources, mating opportunities, and environmental conditions in ways that we can barely imagine. Every movement through these depths follows patterns established by creatures whose ancestors saw the rise and fall of the dinosaurs, whose migration routes were old when the first humans looked upon the sea and wondered what lay beneath its surface. The paths traced by deep-sea eels across ocean basins connect spawning grounds that have remained unchanged since before the Mediterranean Sea existed. The hunting territories of colossal squids encompass areas of ocean floor that have been their domain since the southern continents were joined as Gondwana. The mysteries we have explored tonight represent more than scientific puzzles. They are reminders of the profound humility that comes with true knowledge. Each time we think we understand the limits of life in the deep ocean, new discoveries push those boundaries further into the realm of the impossible. For every question we have answered about the deep ocean, a dozen new mysteries have emerged, each one more intriguing than the last. For every creature we have discovered, countless others remain hidden in trenches and abyssal plains that no human eye has ever seen. The technological challenges of exploring these depths continue to humble our most advanced engineering. The pressure that exists at the bottom of deep ocean trenches is so intense that it would compress a human body to the size of a marble in milliseconds. Yet life not only survives there but thrives in forms so perfectly adapted to these conditions that they cannot exist anywhere else. Our most sophisticated submarines can visit these depths only briefly, while the creatures that live there call them home for centuries. The 52 Hertz whale continues its solitary journey, calling into the darkness with a voice that belongs to no known species, reminding us that loneliness and persistence can coexist in the same vast heart. Its song has been tracked across ocean basins for over 3 decades, a consistent presence in the acoustic landscape of the deep Pacific. Scientists continue to search for this whale, hoping to finally observe the creature behind the voice, but it remains as elusive as ever, a reminder that the ocean still holds secrets that resist our most determined efforts to uncover them. Somewhere in the Antarctic depths, colossal squids drift through their alien realm, their basketball-sized eyes watching for prey or predators that exist beyond our current understanding. These massive predators represent the pinnacle of invertebrate evolution, creatures so perfectly adapted to their environment that they have become virtually invisible to human observation. Their domain encompasses some of the most remote and hostile waters on Earth, regions where the combination of cold, darkness, and isolation has created ecosystems unlike anything else on our planet. In the deepest trenches, Hadal snailfish glide like ghosts through pressures that would destroy any surface creature, proof that life finds ways to thrive in conditions we consider impossible. These translucent beings exist at the very limits of where complex life can survive, in environments more extreme than the surface of many other planets. Their very existence expands our understanding of the possible, suggesting that life might exist in places throughout the universe that we had previously written off as uninhabitable. The ocean remembers the songs of creatures we have silenced, the migrations we have disrupted, the connections we have severed between surface and depth. It holds within its vast memory the chemical signatures of every age, the DNA of every experiment in living that evolution has attempted over billions of years. The deep sea serves as a repository for genetic diversity that took millions of years to accumulate, a library of biological solutions that represents billions of years of natural research and development. In its deepest places, time moves differently, measured not in human moments but in geological epochs, where the concept of now includes centuries of the past and future. The life cycles of deep-sea creatures operate on timescales that dwarf human experience. A single individual Greenland shark may live through the entire history of a human nation. An eel larva may drift through the ocean for longer than some human languages have existed. These creatures remind us that our human perception of time is just one way of experiencing the flow of existence. Perhaps most remarkably, the deep sea continues to surprise us. Every expedition returns with evidence that challenges our assumptions about life itself. We discover creatures that should not exist according to our current understanding of biology, ecosystems that operate on principles we have never imagined, and connections between life and environment that reveal new layers of complexity in the web of existence. Each new discovery forces us to expand our definitions of what is possible, pushing the boundaries of known biology further into the realm of the extraordinary. The pressure that would crush our submarines nurtures creatures so delicate they dissolve when brought to the surface. This paradox illustrates the profound specificity of deep-sea adaptations, where life has evolved to thrive in conditions that are instantly lethal to organisms from other environments. The darkness that would blind us illuminates a world of biological light shows more complex than any human display, where creatures communicate through patterns of bioluminescence that rival the most sophisticated laser shows in their complexity and beauty. The cold that would freeze our blood warms the hearts of ancient sharks whose lives span centuries, creatures that have learned to use the extreme cold as a tool for extending life rather than ending it. The emptiness that would drive us mad with loneliness hosts communities of creatures whose social structures we are only beginning to understand, complex networks of interaction that span vast distances and operate according to rules we have yet to decipher. In this alien realm that covers most of our planet, we are reminded that Earth itself remains largely unexplored. We have better maps of the surface of Mars than we do of our own ocean floor. We have identified more species of insects in a single rainforest than we have species of deep sea fish in entire ocean basins. We know more about the composition of distant stars than we do about the ecosystems that exist in the deepest parts of our own world. The creatures of the deep sea are not just curiosities or remnants from a simpler time. They are active participants in the systems that regulate our planet's climate, chemistry, and carbon cycle. The migrations of bioluminescent organisms transport nutrients between the surface and the depths in daily movements that represent some of the largest mass movements of life on Earth. The feeding activities of deep-sea creatures process organic matter and sequester carbon, playing crucial roles in global climate regulation that we are only beginning to understand. The very existence of these ecosystems influences ocean circulation patterns that affect weather systems worldwide. The deep sea acts as a vast reservoir for heat, carbon, and nutrients, moderating the Earth's climate in ways that make life possible at the surface. Without the biological processes occurring in the deep ocean, the entire planet's environmental systems would function differently, and life as we know it might not be possible. As climate change accelerates and human activities increasingly impact even the most remote parts of the ocean, the deep sea faces unprecedented challenges. The expansion of oxygen minimum zones threatens creatures that have survived unchanged for millions of years, potentially destroying adaptations that took geological ages to perfect. Ocean acidification alters the chemistry that allows deep-sea organisms to build their shells and maintain their cellular structures, threatening to unravel food webs that have been stable for millennia. Deep-sea mining threatens to destroy habitats that took millions of years to develop and that we have barely begun to study. The slow growth rates and extended lifespans of many deep-sea organisms mean that damage to these ecosystems might be irreversible on any human timescale. We risk destroying forms of life and biological processes that we do not yet understand, eliminating potential solutions to challenges we have not yet learned to recognize. Yet the deep sea also offers hope. In the adaptations of its creatures, we find potential solutions to human challenges that could revolutionize technology and medicine. The pressure resistance of deep-sea organisms could inspire new materials and technologies for everything from spacecraft to medical devices. The longevity of Greenland sharks could unlock secrets relevant to human aging and disease, potentially leading to breakthroughs in extending healthy human lifespan. The efficiency of bioluminescence could revolutionize how we think about sustainable lighting and energy use, offering biological models for technologies that produce light without heat or environmental impact. The metabolic adaptations of deep-sea creatures could inform new approaches to medicine, agriculture, and biotechnology, providing biological solutions to challenges ranging from food security to environmental remediation. The languages of light that illuminate the abyss remind us that communication takes forms we have never imagined, suggesting new possibilities for information transmission and storage. The survival strategies of creatures living at the edge of the possible expand our understanding of what life can achieve, providing inspiration for engineering challenges and space exploration. The ancient wisdom encoded in the genes of deep-sea organisms offers insights into the history of life on Earth and perhaps its future as well. These creatures serve as models for resilience, showing us how life can persist and even thrive in the face of extreme challenges. Their adaptations represent millions of years of testing and refinement, biological technologies that have been proven over geological timescales. By studying these organisms, we learn not just about the past and present of life on Earth, but about the possibilities for life elsewhere in the universe. In the end, our journey into the deep has revealed that the ocean is not just a body of water that covers our planet. It is a living library of evolutionary experiments, a repository of solutions to challenges we have not yet learned to ask about, and a reminder that the story of life on Earth is far from finished. In its deepest places, new chapters are being written every day in languages we are only beginning to understand. The deep sea represents the largest habitat on our planet, yet it remains more mysterious to us than the surface of the moon. It is home to the majority of living space on Earth, yet we have explored less than 5% of it. In its vast expanses, evolution continues to work its magic, creating new forms of life and refining old ones in response to challenges and opportunities that exist nowhere else. What else waits in the dark? What other impossibilities drift through trenches we have never mapped? What songs echo through waters no human has ever disturbed? What forms of consciousness move through the eternal night of the abyss, carrying within their ancient cells the memories of a planet we are only now learning to see? What connections exist between surface and depth that we have never suspected? What cycles of life and death, growth and transformation, connection and isolation play out in the darkness beyond our current understanding? The answers lie waiting in the darkness, patient as they have always been, ready to reveal themselves to those brave enough to descend into the unknown and humble enough to listen to what the deep sea has been trying to tell us all along. The ocean remembers everything, and in its deepest places, it continues to dream new forms of life into existence, crafting impossibilities from the raw materials of pressure, darkness, and time. As we surface from our journey into the abyss, we carry with us new questions rather than complete answers, new mysteries rather than simple solutions. The deep sea has shown us that our planet is far stranger and more wonderful than we imagined, that life is far more resilient and creative than we understood, and that the future holds discoveries that will challenge everything we think we know about the possible. In the depths where no human has ever been, where no light has ever shone, where time moves to rhythms older than continents, life continues its ancient dance, writing new verses in the epic poem of existence that began billions of years ago and shows no sign of ending.